Linear algebraic equations have many applications, and let us mention one simple geometrical meaning. If we have two equations for two unknowns, say x plus y is 5 and 2x minus y is 1, then the first equation alone is the equation of a line in a plane. X plus y is 5 is a plane like that, is a line like that. And the second equation alone is again an equation of a line. This looks like y is 2x minus 1. And if we want to satisfy these two equations simultaneously, then this is done when x and y are exactly coordinates of this point, the intersection of the two lines. So each equation alone is an equation of a line, and the system as a whole describes the common points, the intersection of all these objects. Well, and you can imagine that two lines may indeed intersect in one single point, or it may happen that two lines have infinitely many solutions, or it may happen that two lines, if they are parallel, have no points in common. From this interpretation you see that it is not possible that a system like that has two solutions. Two lines may intersect in no point, 1 point, or infinitely many points. No other case. What about three unknowns? If we have three equations for three unknowns first, then in the three-dimensional space, such a linear equation for three unknowns corresponds to a plane. In this case, it would be a plane that cuts this triangle, and then it goes to infinity in each direction. If we have two equations, say, then we have two planes. And two planes, in a typical case, intersect in a single line, or they may be parallel with no intersection, or they may be identical with infinitely many intersections. And if we have three equations, then this describes the intersection of three planes in a three-dimensional space. In a typical situation, two planes intersect in a common line, and the third plane cuts this line in one single point. So in a general situation, if the coefficients are, say, some numbers from some experiment, independent values, then there will be one solution, 1 point. But it may happen that three planes, like pages in a book, intersect in one common line. That is possible. Or if two planes coincide, then the intersection with the third plane may be again a line. Or it may happen that these three planes have nothing in common. Say if two planes are parallel, or if they are not parallel, but if the third plane is parallel to their intersection. That means no point. And again, you see that it may happen that no intersection, one intersection, or infinitely many intersections. So this corresponds to a common point of lines in a plane, and this corresponds to intersection of three planes.